Good morning, friends. In this slide we are going to learn this is the structure of maltose, but how this nomenclature is given. For that we have to take first glucose into consideration. So this is simple structure of glucose in which we have not written the substituents, but these bonds which are equatorial, right? And these are the bonds which are axial. So this is the simple chair conformation of glucose. Now if I add substituents to the structure of glucose, then you will find this is axial OH, this is equatorial OH, equatorial OH, equatorial OH, and CH2OH is always equatorial. These are the axial hydrogen, 1, 2, 3, 4. Now this OH, which is carbon 1, this is carbon 1, and OH group, if it is axial 1, the compound, the isomer is known as alpha D glucose. Suppose this OH occupies the equatorial position here, then it is known as beta D glucose. This particular structure can be also written as this particular structure in which I have omitted the presence of hydrogens. So this is the structure of alpha D glucose. Why do you want this structure alpha D glucose? It is because our maltose is combination of two monosaccharide units and both are alpha D glucoses. So this is the actual structure of maltose. Now we would like to see that how this nomenclature is given to the structure of maltose. So now first of all, the first glucose unit, which is known as parent glucose unit here, which is on the right hand side, for example, the carbon number 1, carbon number 2, carbon number 3 and carbon number 4. This is carbon number 5 and this is carbon number 6. In case of the left hand side glucose unit, this is our carbon number 1, this is 2, this is 3, 4, 5 and this is carbon number 6. Now, as a whole unit, this is the carbon 1 of the maltose, and as the OH occupies the equatorial position, this is beta anomer of the maltose. Here we have seen that this is alpha anomer of glucose because this is the monosaccharide, and OH at carbon 1, this is carbon 1 for glucose, occupies the axial position. Coming back to the maltose. Now this is first glucose unit, this is the second glucose unit. On the red one, the first one, position number 5, you will find some group R is attached. So if I consider this monosaccharide unit as R, then this is R-O to the position of first glucose, which is at position number 4. Therefore, I have written 4, and the group R is connected via oxygen. Therefore, it is 4-O via oxygen. And into bracket, I have written some letters in the white chalk. It is because this is my R. Here also it is in white color, but that will be afterward. So 4O, now this is parent structure, first glucose unit, and therefore I will write D, glucopyranosyl. So this particular glucose unit, there is one substitution on position number 4, which is my R, therefore 4-OR glucopyranose. Now what is my R? Here this is your R, but this R is again glucose. So we know that if it is methane, we will write CH4, but if methane is as a substituent on benzene ring, then it is methyl benzene. So here it is not full glucose, but removing one of the valency, it is in the form of R dash. Therefore it is, instead of glucose, it is glucopyranosyl. So SYL, because this part is as the substituent. Now look at this one. This is alpha configuration. Why? Because here this white glucose unit has the OH on the axial position. Therefore, the geometry at this particular glucose, which is white one, is the alpha type. Therefore, this is alpha D glucose in the form of a substituent. Therefore, alpha D glucopyranosyl. It is connected on 4th position to the parent glucose unit. Therefore, 4-O, this is R, that is alpha D glucopyranosyl, and this is the main structure, D-glucopyranose. Therefore, they will ask, prove that maltose is 4-O-gluco alpha D-glucopyranosyl D-glucopyranose. So this is how we can understand the structure of maltose. Thank you.